Okay, so this unit is all about, or this video is all about unit conversions. Whoa. And so we'll focus on one, how to do unit conversions, and also two, importantly, why we need to do unit conversions sometimes. And there will be two main reasons that I talk about why we might do unit conversions. That's definitely not all the reasons you might do a unit conversion, but two major ones. So the first problem we'll look at is Denaya, who is on vacation in Japan. She has $35 looking to add 10 gallons of gas to her car's tank, and then therefore she can afford this unit rate of $3.50 per gallon. If any of you are interested and don't already know where that number came from, that's just from the $35 that Denaya has divided by the 10 gallons that she needs, which is where, again, that $3.50 per gallon came from. That's not a unit conversion, and that's certainly not the focus of this problem. But if any of you were wondering and wanted to know. Okay, so she can afford that much gas, but she drives up to this gas station in Japan, and of course the price isn't listed in dollars per gallon, it's listed in yen per liter. A lot of the world uses liters for their liquid volume measurements instead of gallons. So this brings us to reason one that we might need to do unit conversions. We can't compare two measurements or two quantities unless they're in the same unit, right? Like off the top of most of our heads, certainly my own head, I'm not able to tell whether 560 yen per liter is more or less than $3.50 per gallon. So we need to get those into the same unit, because if they're in the same unit, it's very easy to tell which is bigger, whatever the bigger number is. And for this problem and many problems, there's not necessarily a right path to take to get there. We sort of have two choices. We can either convert the $3.50 per gallon that Denaya can afford into yen per liter, and we can compare those numbers, or we can convert this 560 yen per liter into dollars per gallon and see if Denaya can afford the cost of the gas at this station. I'm going to choose to convert the yen per liter into dollars per gallon just because in the US it's more intuitive to me to get things in dollars per gallon just because that's what I'm used to. But if you did it the other way, you should still get the same answer. You should still come to the same conclusion even if you end up with like some different numbers. So we have this measurement, 560 yen per liter, and I'm just going to use capital L, that's the shorthand for liter. And then we need to do two different conversions here, which is why we're given these two different conversion factors. So again here, there's not one right order that we would do this in, but we need to do a conversion for dollars to yen and also gallons to liters. Just because I have the orange pen up, I'll go with the liters to gallons. I'm definitely mixed that up there. Liters to gallons first. So right now we have liters in the denominator, right in the bottom of this fraction, in our given measurement of this 560 yen per liter. And we want to get rid of those liters because in our desired unit we want gallons to be in our new denominator. So to cancel out liters, we need to put liters up top in our conversion factor. And since we want to end up in gallons, and we have our conversion factor that's between liters and gallons, those are the two parts of this fraction that we're multiplying by. And then to figure out or remember what numbers we need to put next to these, we just go over to our conversion factor here, and the pen that I have is a little bit over that, the pink and orange pens, but it's 3.8 liters is equal to 1 gallon. And this seems like a weird step, like doing a unit conversion in this way potentially if you haven't done things like this before. But essentially what we're doing is it's almost like we're multiplying by 1, right? We know that when you take some number and you multiply it by 1, the number stays the same. It's almost like we're doing that because this 3.8 liters and 1 gallon, they're equal to each other, right? That's what this conversion factor tells us. So just like if we had, 4 over 4, we know that equals 1. 3.8 liters and 1 gallon, it's almost like that's 1 because these two things are equal to each other. So we're going to get a different number, but we're not changing what the actual thing is. We're not changing the unit rate of this gas price at this Japanese gas station. We're just putting it into different terms, putting it into different units. That's a little bit of an aside, but if you were wondering why we're allowed to do stuff like this, it's because of that. We're essentially multiplying by 1, just putting it in different terms. Okay, so if we look here, our liters should cancel out. Oops. And our gallons are left over in our denominator, which is good. That's what we want in our desired unit. We want to convert to dollars per gallon. But we still have these yen left over. So we need to do one more conversion for that. And again, we're going to do another one of these multiplication steps, or like set up another fraction. So right now we have yen in our numerator. So to cancel them out, I'm going to put the yen in the denominator here. And we have a conversion factor between yen and dollars. So the dollars is going to be the other part of this fraction. And then again, to remember what numbers we put next to each of these units, we just go over to our conversion factor. And again, the orange pen is a little bit over this, but it's 140 yen approximately is equal to $1. And so now, if we look at our sort of big chain of fractions here, we have yen up top and yen in the bottom, numerator and denominator, so they will cancel out. One important note is that the numbers don't cancel out, it's just the units that we're canceling out. We'll see what we do with these numbers in just a second. That's why I have this calculator open over here. Okay, so let's go ahead and use this calculator. And just like you would do with fractions that you're multiplying, we're just going to multiply by all the stuff up top and divide by all these numbers down below. So we have 560 times 3.8 times 1. I'm just going to hit enter so that I have that. Divided by 1, divided by 1, divided by 140. Okay. And probably some of you are thinking, you could have skipped some of those steps, and you're absolutely right. I did not need to write any of the multiplying or dividing by 1, because we know that those don't actually affect the answer. But I did it just to be thorough. Some of you might also want to, just if you're more comfortable with this, some of you might instinctively go like 560 divided by 1, so like breaking each fraction up, times 3.8 divided by 1, times 1 divided by 140. Again, you should get the same answer no matter what. That's an important property of math, that the order that you multiply and divide stuff in doesn't affect your final answer. What we find here is that the price of gas at this gas station is $15.20 per gallon. In fact, I should have put another 0 there to show our full cents. So the short answer is, if gas there costs $15.20 per gallon and Denia can afford $3.50 per gallon, no, she can't afford this gas. And it's very easy to tell that now that we have these in the same unit, right? That's the whole point of doing this conversion again, is because it makes it very simple to compare measurements if they're in the same unit. And it's sometimes almost impossible to compare units or to compare measurements unless they're in the same unit. So again, that's one big purpose of doing unit conversions. Okay, let's see another purpose of doing unit conversions before we just get into a couple more practice problems in case you need to see them. Okay, so we probably won't do the honors push in this video because I'll leave that to class. But if I'm approximately 878,428,800 seconds old, how old am I in normal terms? Right. So one other reason that we might do a conversion is to put measurements in units that are more intuitive to us. Right. So it's just like, we don't think of distances that we drive in terms of centimeters usually. We usually think of them in terms of miles. Right? And we don't think of ages usually in terms of seconds, except for maybe very, very newborns. We think of ages in terms of years and months maybe. So, again, that is another big reason to do conversions, is to make units and to make our measurements easier for people to understand. And so that's what we're going to do here. So I'm this many seconds old. Let's figure out how many years I am old, and we'll use some unit conversions or some, equivalences that we're all familiar with. So we have this 878,428,800 seconds, and I am feeling old. So one thing that I want to point out about this problem is that we have a basic measurement here. It's not a complex unit or anything. It's not like seconds per anything, not like the last problem where it was dollars per gallon. It's just this many seconds. So you kind of have an option. There's not one right thing to do, which I realize is frustrating. You can just put a 1 here to remember that you didn't like forget something. But we don't need a unit in this denominator because, again, there isn't a unit. It's not seconds per anything. So I'm just going to put 1 as a placeholder to remind myself that I didn't forget anything. And then the rest of this problem, all the conversions, will be about the same as what we did last problem. And I just want to take a second to map out what my conversions are going to be. So I'm going to go from seconds, and then it's easy for me to think about like going from seconds to minutes because I know how many seconds are in a minute. And then we know how many minutes are in an hour, hours in a day. And then from here, you might be thinking about like we go from days to weeks, weeks to months, months to years. The possible issue with that is that there aren't always the same number of weeks in a month, and we can skip some of those steps because we know exactly how many days are in a year. Assuming that we're not in a leap year, and I will be kind of making that assumption that we are not in a leap year, just for simplicity here. So we'll go from days to years. Alright, so to go from seconds to minutes, right now we have seconds in our numerator, so I'm going to put seconds in our denominator so that those units will cancel out and we'll get into minutes. And again, the equivalence that I know is seconds to minutes. And then to remember what numbers go next to each one, we can maybe just write out that quick equivalence. We know 60 seconds are in 1 minute. So I'm going to put a 1 next to the minute and a 60 next to our seconds from our equivalence. So we've made it from seconds to minutes. Now we're just left over with minutes. But that's not where we're stopping because, again, we still don't usually understand people's ages in terms of minutes. We usually understand them in terms of years. So let's do another one of these conversions, and we know that 60 minutes are in 1 hour. So right now we have minutes in the numerator left over, so I'm going to put minutes in the denominator so that those will cancel out, and I'm trying to get to hours in this step. And I know 1 hour is equal to 60 minutes. And so I will do that. And now we can see our minutes cancel out. And so we're on track nicely. And I'm just going to have to scroll over a little bit so that we have room. And then we're going to get to days next. And we know the equivalence there between hours and days is that there are 24 hours in a day. Even if some of us would like more of those hours, maybe some of us would like fewer of those hours. Okay, so we've got 1 hour in our numerator, and we want to cancel it out, so we're going to put hours in the denominator of our conversion factor here. And again, we're trying to get from hours to days, so days will be the other part of our conversion factor. And then to remember what numbers we need to put in here, we're just going to use that equivalence. 24 hours is 1 day. We can see our hours will cancel out, and we're left with days. So we are very close. We just have to use one more equivalence to get from days to years, and that will be our 365 days in 1 year. Oh boy, my handwriting is getting bad, but 365 days in 1 year. Okay, and we're left with days in our numerator, so I'm going to put days in our denominator down here so that those will go away. And we have 365 of those is equal to 1 year. Okay. So let's zoom out a little bit and see what all we need to plug into our calculator. Okay, so again, same as last problem. You can either think of this as like each fraction and like get each fraction. You would make sure that you use parentheses if you do that. I usually find it easier, especially depending on the kind of calculator that I have, to just multiply straight across. So multiply all the numerators, divide by all the denominators. So that's what I'm going to do here. So we have 878,428,800 seconds. And then I'm going to skip steps that I know I don't need to do here. So I'm not going to multiply by any of the ones. I'm not going to divide by the ones because I know that's not going to affect my answer at all. Oh, and one thing I want to do before I do that, I want to cross out our days so that I can be sure that I'm left with years to remind myself of my units. Okay, so let's come back over to this calculator, and we are going to divide by 60, divided by 60 again, divided by 24, divided by 365. Okay. So we have our answer, 27.85 years. And again, if you're ever not sure what units all your work led to, just go back to like the conversion that you set up. So that's what I'm looking at here. The only units that aren't canceled out are years, so that tells me that the unit for my final answer is in years. Okay. To figure out when my birthday is, you would have to, the way I would recommend doing it is figure out the fact that I'm almost 28, figure out how many days are in like the remaining 0.15 years, and then sort of go backwards from there. But I'm not going to show that here. We'll do that in class. Some quick other examples, just in case you need them at this point. There won't be anything terribly new. We've gone over the two reasons that you do unit conversions. One would be that in order to compare measurements, they have to be in the same units. Two being that we can make units and measurements much more intuitive if we put them in units or measurements that we tend to imagine them in. For example, age in years instead of seconds or minutes. And then we're just going to practice some more setup in case you need that. So you're running a mile for the track meet. You know that your personal best mile time is 5.9 minutes. The stopwatch is at your meet today. Measure your time as 345 seconds. The question is, did you set your new personal best? So again, we can do this in either of two ways. You can convert this time, 5.9 minutes, into seconds, or you can convert our seconds into minutes. In fact, maybe I'll show it both ways. So 345 seconds. We'll convert that to minutes first. And again, since this measurement is just seconds, not seconds per anything or anything like that, I'm just going to put it over 1. And the equivalence that we know is that 60 seconds are equal to 1 minute, of course. And then to make sure that we're dividing or multiplying by the right thing, our seconds are in the numerator right now, so in order to cancel those out, I'm going to put the seconds in the denominator in our conversion factor. And then we're trying to get into minutes. And then to figure out or to remember what numbers to put next to these, it's 60 seconds is equal to 1 minute. And so we end up with 345 seconds. Our seconds cancel out, and we're just left with minutes, which is good. That's what we want. Divided by the 60. And so we get 5.75. And then we should be asking ourselves, if we don't already know, what our units are. And the unit that we're left with here is minutes. That would be our answer. So to answer this question, if your mile time was 5.75 minutes and your previous personal best or personal record was 5.9 minutes, then yeah, you did set a new personal best at this track meet. Again, you could do this in like going the other direction, converting these minutes into seconds like for your previous best. If you did that, you would get 5.9 times 60. I won't show that, but you would get 354 seconds as your previous best. And so then you would see, okay, if your time today was 345 seconds and your previous best was 354 seconds, then yes, you did set a new personal best. Again, same conclusion, just with like different numbers because you're working in different units, but the conclusion is the same. That is that. And then one more of these like compound unit conversions. So we have, for whatever reason, this conversion that we need to do of 174 pounds per week into some number of kilograms per day. Let's take a second to write out some conversion factors we need here. 1 kilogram is about 2.2 pounds. And we know a week is 7 days. Okay. So let's start out with our given unit. 174 pounds per week. And the order that we do this in doesn't matter. We could either convert pounds or weeks to kilograms or days first. It doesn't matter. Just because of the order that I wrote it in, I'll go with the kilograms to, or the pounds to kilograms conversion first. So right now we have pounds in our numerator. So to cancel out pounds, we're going to put that in the denominator of our conversion factor. And then we're trying to go from pounds to kilograms, so the other part of this conversion factor is kilograms. And then to remember what numbers we put there, we just look at our equivalents, and we know it's 2.2 pounds is equal to 1 kilogram. And we can immediately start doing our cancellations of units. Again, we're not canceling the numbers, just the units for now. Okay, but we still haven't figured out, or we haven't converted and gotten rid of weeks, right? We want weeks to become days. So right now, weeks in this given unit, the 174 pounds per week, the week is in the denominator. So in our conversion factor, we need to put weeks in our numerator so that those will cancel out. And we have 1 week is equal to 7 days. So we can see that our weeks cancel out and we'll just be left in terms of the units that we have left in kilograms over days, which is exactly what we want. And now we'll come over to our calculator, and again, I'm going to skip the steps that we know we don't need to do. I'm not going to do any of the multiplying or dividing by 1. So 174, no other non-1 numerators, divided by 2.2. and divided by 7. And so we get 11 point, depending on where we're rounding, we'll say 30 kilograms per day of whatever this is. So big takeaways, sometimes we need to convert units to compare measurements, sometimes we need to convert them to make a measurement more intuitive, and make sure you show your cancellations. It'll always keep you honest and like keep you from making simple mistakes if you stick to this and show your cancellations and set your fractions up this way.